Good to see you all again. This is our final, maybe, digital skills workshop. We've gone through 6 workshops. Today's the 6th and final workshop. After covering, we started off with Gen AI, then we went into web and mobile app development, yes, game design, then storytelling, and then marketing. And today we're really, really happy to have DataKind here to introduce data science to us. And yeah, I would like to really extend my appreciation to Ratri and Srinath for coming in at such short notice so that the participants could have this workshop before we move into the solution building phase, which is starting on Monday. Yeah, and I think we're happy that we're going to do this before our entrepreneurial thinking workshop tomorrow. So yes, without further ado, I'm going to hand over to Srinath to kick things off.
Thank you. Thank you, Yakban. Good morning, everyone. Glad to see so many people virtually. I wish at least one of you had turned on your camera. Can't see anybody here. Good to see everyone. I hope you are all doing well. Thanks for joining this. Thank you. Thank you, Wang Soan, for turning on your camera. Good to see everyone. Thank you, everyone, for joining on this Saturday morning. I hope you are doing well. So me and my colleague Ratri are here to represent DataKind, and also my colleague Vibeng, who is also from DataKind. So we three here. Hi, Vibeng. We three are here on behalf of DataKind to introduce data science to the wonderful problems and solutions you're coming up with. Hope the data science introduction that we are going to provide will be useful to address the very important climate-related problems that you're all working on. Okay, let me share my screen. I'll try to go as slow as you can, because I know that there are many people from many different backgrounds, with some people who are advanced users, some people who are not so advanced users, and so on. I hope you are able to see my screen. Yokpin, can you just confirm if you're able to see the screen?
Not right now.
Okay. Thank you for that. Let me stop sharing. Okay. Okay, how about now?
Yes.
Okay, thank you so much. So this is going to be a very basic introduction to data science, and that's why we have named this session Data Science 101. So as I mentioned, I am Srinath at the bottom of this slide. That's my name. And then Ratri, my colleague, who is also from DataKind, will also be talking during the session in the later half of this presentation. So before we start off, I just want to briefly ask you to mention which country are you from in the chat, so that will give me an idea of the distribution of countries that we have here. Okay, thank you, Leon, from Malaysia, Thailand, Vietnam, Indonesia. Okay, we have good coverage of all the ASEAN countries here. Singapore, Rodney, hi. I'm also from Singapore. Oh, India, Pooja, hi. Pakistan, wow, nice. Myanmar. Okay. Okay, keep it coming. Just briefly mention which country are you from? Oh, Cambodia. Nice. So since we have people from different background and different languages, I'll try to go as slow as I can. But in case you feel that I'm speaking very fast, just briefly mention on the chat. I will try to slow down. I'll be seeing the chat as well in my other screen. So if I happen to look down, it's because I'm looking at the chat here. Okay, let's proceed. This is me, Srinath. I am a data enthusiast. I keep learning new things about data science and technologies and so on. I have a PhD in computational biology from NUS Singapore. Currently, I'm a lead in tertiary hospital in Singapore called Changi General Hospital. I frequently write technical blogs about data science at basic and even advanced levels on medium.com. You can find my profile on this QR code. You also can find some of my posts on LinkedIn as well. You can connect with me on LinkedIn here. I have about 12 years of experience in research, consulting, private consulting, and also in healthcare settings. So that's about me. Let's move on to the actual topic. So this is the agenda we have. A brief opening to the whole agenda, the presentation itself. Then we'll have a quick poll to understand at what level of data science maturity you are, so that we can either pace up or pace down the whole talk. Then I'll provide introduction to data science. That will be the major part of this talk. And then we have Q&A. Although the Q&A is mentioned here as 10 minutes, at any point, if you have a question, please put it in the chat. Since I'm always looking at it, I can take a pause, answer your question, and then move on with my slides. So ignore this Q&A 10 minutes. Assume that the Q&A is for the entire session of this 35 or 45 minutes. Then my colleague Ratri will take over to explain how data science and AI can be used in your climate space. What are some of the problems that we at DataKind have worked on in the past using data science, which are related to climate. I'm not sure. I'll leave it to Ethiopia to decide if we'll have a breakout session later or not. And then we'll have closing remarks. Okay. So let's start off with the poll. I think my colleague would have initiated a poll. How familiar are you with data science in climate and sustainability? So I think the poll is already starting. Okay, I see some results. Okay. Okay. And I also see that I have few LinkedIn requests coming up. Okay, we have few more seconds for the poll to end. Okay, majority of you, about 60% of you are not familiar how to use data science or with data science in climate and sustainability. Okay, none of you seem to be very familiar. About 40% of you are somewhat familiar. Okay, I think that's it. I'm going to stop the poll now so that I have a good idea of how to proceed with my slide. Okay, let's move on. So these are some of the terms that we keep hearing in media, in research articles, in any and every presentation these days. In fact, there are three terms, three buzzwords, if you have in your any proposal, will be sure to get you funding. One is AI, artificial intelligence. The second one is sustainability. And the third one is climate change. So if there are any of these, one or combination of these words in your pitching session, you are sure to get fund. So that's why one of my colleagues who is in another hospital in Singapore, he wants to write a proposal using all three. He wants to use AI in a sustainable fashion for climate change problem. I'm sure he's going to get millions of funding for this. And he wants me to be part of that proposal as well. However, coming back to this point, are these same? Is artificial intelligence, machine learning, predictive modeling, data science, are these same? Or are they different? So that's what I'll try to briefly answer here before we go into data science. Oh, one more thing. This Dilbert, it's a very good website if you want to introduce some concepts in a comic fashion. They have comic strips for all kinds of concepts and all kinds of feats. So you should take a look at this Dilbert website. Okay. So this is how the whole umbrella of artificial intelligence is based. Artificial intelligence is a big umbrella within which we have machine learning, and within machine learning we have deep learning. And artificial intelligence dates back to 1950s. Some of the earlier works have been started in 1950s, but due to lack of good computing resources, people had to wait till we get good computing before they proceeded into using artificial intelligence in practice. Similarly, machine learning algorithms were were developed in 1980s itself, but we needed lots of computing to use to run these machine learning algorithms. That's why only in early 1990s or early 2000s, it's when machine learning actually flourished. And then deep learning, which is mainly not mainly, it's primarily targeted at images. If you have image analysis using deep learning will be is very useful. So that's an overarching view of what artificial intelligence is, what machine learning is, what deep learning is. Now we have a new player, a new kid, and that kid's name is called generative AI or Gen AI, which is coming within the deep learning space. So artificial intelligence, it involves computers. Instead of giving you an actual definition, let me give you an example that you will know. I'm sure you all would know this Amazon's Alexa or Google Assistant or even the Siri on your iPhone. These are all considered artificial intelligence. So they can think on their own. They use algorithms within machine learning, deep learning, and even these days they are using generative AI algorithms to answer any questions that you ask. Let's say you ask how long do I need to run to burn off my calories? So it will use some of these algorithms to come up with the answers. So in a nutshell, your Google Home or your Alexa is like artificial intelligence, which uses any or a combination of these algorithms to answer your question. I hope at this point you have a clearer idea of what AI is, what machine learning is, and how they are all structured. Let's move on to the actual crux of this topic, which is the introduction to data science. So there are two terms here, data and science. Let's try to split it and understand what each means and how they can be combined. What is data? It's a raw information that is collected by computers or even collected by humans and stored to be used by computer programs. And when we derive the insights, then we add meaning to the data. Data by itself might not be useful, but data, when analyzed and provided with insights, will be useful. So that brings us to the topic of data science. So data science is a study of data, as I mentioned, to extract meaningful insights. You need to have some insights that is non-trivial, that is important. Okay, noted, Rit. So it's a multidisciplinary approach that combines practices from math, statistics, artificial intelligence, and computer science. So that is what data science is. It uses data, uses algorithms or techniques from math, AI, computer science to give good insights. So data plus insights is what we want. So that is what data science briefly is. So usually there are three outcomes that data can achieve. One is to observe. Second one is to reason. Why? Third one is to act. How do we do? What do we do with this? So in observe, what we do is we just take a snapshot. Let's say you collect today's weather data or today's customer data in your store. How many customer did I serve past month or past week? How was the temperature yesterday? How is the temperature today? What is the most trending topic on Twitter or X these days? These are all a snapshot, which will give me information at a particular time point. So that's one outcome. Second one is to reason. Based on the snapshot, what do you think will happen next? Based on the customers I had yesterday or last week, how many customers customer requests or even customers will come into my store next week? What will the temperature be like 2 days from now? These are the reason or the predictions that we want based on the snapshot that we have. Third one is to act. Let's say you have all this information and you can predict how many customers will be there 2 days. How can you act based on that? Let's say you know there will be 100 more customer requests next week based on your prediction. What can you do about it? Okay. Is somebody going to ask a question? Okay. So based on information, what can you do to make sure that the 100 new customers that you'll be getting can be serviced well? So maybe you can deploy more manpower. So if the temperature is going to be very hot, maybe you can add an extra layer of a sunscreen or bring along the sunblock when you go out and so on. So these are the things that you can act upon. So the three outcomes are: first, you observe what is happening. Next, you predict what will happen. Third, what can you do about it? So these are the typical three outcomes that are achieved using any good data. I hope I'm going slower. I'm speaking slower. Let me know if I'm very fast or you're not able to understand. This is also an extension of what was presented. Thank you, Leon, for the confirmation. This is an extension of what I shared in the last slide. Usually we have four types of analysis that you can do. One is the descriptive, second is the diagnostic, the third one is the predictive, and the fourth one is the prescriptive. So these are very common terminologies that are used in data science. First one is descriptive. What is the actual finance statement telling you? How many staff do we have in our store? This is descriptive. It is just describing what is in the data. Next one is diagnostics. Why? Why do we have so much dollars deficit? Let's say in terms of financial statements. Why are the KPIs going up or going down? Why do we have a lack of staff, for example? So this is diagnostic, to understand what happened and why it happened. The third one is to predictive. Based on the information in description of the data, can we forecast how many staff we need in the next month, for example, or forecast your cash flow for the next month, and so on. The final one is prescriptive, which is the factor that we can use to reach an output for a particular scenario. For example, it focuses on finding an actionable insights based on a combination of diagnostic and prescriptive. So in our example of the number of staff in our store, let's say you found that we are short of 10 staff for the next week, where I'm going to see more customers coming in. So what can you do about it? We can hire more, or we can hire, if it is going to be only 1 week where we get more customers, we can hire more part-time staff. So that's what prescriptive analysis is going to tell. So descriptive is just describing what your data has. Today's temperature is like this. Today's staff count is like this. Number two is the diagnostics. Understand why is it like that? Why is the temperature like this? Why do we have only so little staff and so on? The third one is predictive, where we predict what's going to happen next day or next week and so on. Descriptive is, so what? What can we do about it? So these are the four types of analysis that you can perform. Depending on your objective, you either perform one of them or a combination of them. Okay, that's about data analysis. Now, we have a question for you. Before I launch the poll, no, this is not a poll, sorry. Before I go on to the next session, are there any questions from you about data or data science or the data analysis that I'm showing here? If you have any questions, please feel free to ask in the chat. Okay. Let me move on. So now, what kind of jobs involved? Is it only people working in Microsoft or Google? Are they the only jobs that use data? And the answer is clearly no. Even chef will be using, he's using data. If you have watched shows like Hell's Kitchen or Master Chef sometimes, so the way they do is they come up with delicious dishes, but what happens behind the scenes is they're also crunching data. The data might not be numbers or text, but they analyze recipes. They analyze how costly the ingredients are. Based on the ingredients cost, they have to price the dish. And what are the customer preferences? So they also conduct market research. They go out to people, ask, okay, what are the kinds of food that people eat these days? What are the kinds of food people don't eat these days? Who are the health conscious people? So they get all these data, they analyze, and then they come up with a menu of dishes. So even a chef uses data and data analysis. Okay, I see a question. There is a difference between AI and ML. So the question for everyone's benefit is there a clear cut, I assume, difference between AI and ML? There is a difference. AI is like having a product which uses ML, machine learning. What would be helpful for our sustainable work if we do not have the background? I think there are lots of tools. I think we'll be going towards the tools and resources at the end of the talk, which you can use to just plug and play. You don't need to code. You just bring your data in, click something, and then you'll get the results. So that's one. Okay. Beyond prescriptive analysis, I think there is nothing else. I think that covers the entire cycle. You see, you start off with the data, you end up with prescriptive. I don't see anything beyond that, but if there is, then I'm happy to be corrected. So coming back to your question on AI and ML, I will touch upon it again in the next section and also in the resources towards the end of my talk. Thank you for the questions. So the other job that involves data is farming. I think this is quite closely related to climate change. As the climate changes, the crops growth might be affected, not might be, definitely will be affected. So even farmers, they collect data through sensors, drones, imagery, and even satellites to monitor the crop health and growth. So they collect what are typically how long does it take for a crop to harvest, how long it took in the past, and so on. So these sensors provide data like what is the growth, what is the humidity, what is the soil content. Oops, sorry about that. So even farming involves data. So there are many ways we can work with data. So these are some of the roles on the left you see. Data engineer, data architect, machine learning engineer, and so on. So each of them have a specific role to contribute towards the entire landscape of data science. For example, a data engineer builds and designs the infrastructure that we need. Let's say you collect tons and tons of data. Where do we store it? How do we process it? And how do we retrieve it? So these are the jobs that are typically done by data engineer. So they maintain the data well, and then they give access to data to necessary people and so on. Similarly, a data analyst analyzes, takes this data from the data engineer, analyzes the data using techniques from statistic, math, or even algorithms like ML. Visualization specialist, they create visual representation to show what is the insight from the data, how is the data, and what are the insights that we can gather from the data. So there are many ways that we can analyze, that we can work with the data. Depending on your interest, your expertise, and your need, you can choose one or many of a combination of them. Typically, these are the softwares that are used, not softwares and the skills that are used, but these are not exhaustive by any means. With new tools and technologies coming in, the list is only going to be increasing. For example, a data scientist need to be aware of all this. He needs to know how to program. He needs to solve problems. He needs to tell a story. Okay, this is the data we collected. This is what the data is telling us, the insights. Based on these insights, I think this is the problem. In order to address this problem, these are my solutions. So the entire pipeline from the data to the actionable insight. need to be provided by a data scientist. So that's about this slide. This is just telling you what are the different roles of different professions within the data science. Thank you for the question, George. This has been on everybody's mind. The question is, are not all these skills substitutable by AI? Maybe in the future, definitely not now, I would say, because some of these, let's go one by one. Programming, yes, it can help you, but to the best of my knowledge and to the best of whatever I've read from experts, it cannot completely solve the programming issue yet. If you give a scenario to it, it can create a base code on top of which you need to add your own things to integrate into your workflow. Problem solving, I don't think so. Even the GPT-4o1 is still struggling with some of the problems. We need humans in the loop to make sure everything is correct. Storytelling, it can give you ideas. Even it can't even create a proper PowerPoint these days. Although Microsoft Copilot is claiming to do so, we can't create. So a short answer to your question, George, is not in the near future. It cannot substitute humans in the near future at all. But what or who can substitute a human, let's say a data scientist, is another data scientist who knows how to use AI. Let's say there is human X, who is a data scientist, human X, who is a data scientist and also knows how to use AI. The second person might substitute the first person, but definitely not AI substituting the first person. Okay, I hope I answered your question. This is one of the most important skills that a data science related person needs: empathy. You need to put yourself in the shoes of the end user to create a data driven solution that are relevant and useful to the person who is going to use it. You should always think from the end user perspective. So empathy actually helps us to create visualization that the other end user understands, not a complicated graph. That's not what is needed. A simple visualization that will capture the essence of what you have done and easy for the end user to understand. So it is really useful to have empathy as a skill, which is sadly not listed here. Okay. Okay, at this point, I would like to take a pause. Thank you for your response. And sorry for the slight delay. Okay, let's go on to artificial intelligence. I briefly touched upon this in the earlier part of my talk. Like, it's a big umbrella within which your machine learning and deep learning and generative AI are there. Let's give a proper definition to these terms. Artificial intelligence is an umbrella term for teaching computers to learn. So that they can think on their own, they can not think, they can answer the questions on their own without any further data needed. So there are different ways of doing it, including machine learning and deep learning. So the way they answer, to answer the questions, it uses machine learning algorithms or deep learning algorithms. So machine learning is most developed and applicable field for this. This one we saw in the earlier umbrella of. So machine learning is interchangeably used with predictive analytics, because predictive analytics, you use some algorithm. It can be a machine learning algorithm, can be even a linear regression to predict something in the future. And statistics guys also use it as statistical modeling. So machine learning actually teaches a computer how to learn from an observation. What are the patterns in the data? What are the anomalies in the data? So it will understand these and then try to predict when a new data comes in. So the computer gets a better at this task as you give it more and more data. As time goes on, it will learn from its own, from the new data, and then it will improve on its own. So something like self-driving cars, the recommendations you see on Amazon or any other e-commerce website, even prediction of health outcomes. So now we have models to predict if a cancer will recur, or what is the risk of me getting diabetes, let's say 10 years down the line, based on my current health condition, my medical history, my family history, and so on. So these are all possible because of predictive analytics using machine learning algorithms. So examples, as I mentioned, some of them, there are many. Computer vision, given an image, can we analyze if it is a cat or dog? That's the simplest example that I can give you. Natural language processing, given a big chunk of text, can we summarize it? Can we extract the sentiments from it? Is it positive sentiment? Is it a negative sentiment? Spam detection is a classic example which has been done, I think maybe 15, 20 years ago. Given an email, should it be classified into a spam or normal inbox? Self-driving cars, recommendation engines, and so on. So there are many examples that are many applications of machine learning in our real life that we see every day. So machine learning, we can further divide into supervised learning and unsupervised learning. So these might be very helpful for some of your problems that I see in the pit stop one. Sometimes you'll have supervised learning, sometimes you'll have unsupervised learning. What is the difference? Supervised learning, you will have a label. In the case of predicting diabetes, you know which patients have diabetes, which patients do not have diabetes. That's the label. The label, if the outcome is positive or negative, whether the email is spam or not, whether the health outcome is positive or negative. That's the label. So data is labeled, it is supervised. The data is not labeled, it is unsupervised. Let's say you want to find a clusters of area within your city where dengue, for example, is popular. Is it in zone A or zone B or zone C, where you don't know where it is popular? So supervised learning, you have a label, you know what the outcome is. Unsupervised, you don't know what the outcome is. That's the basic difference. If you go into details, data is labeled, you know what to predict. You know that you want to predict if the email is spam or not. You know you want to predict if the patient is going to get diabetes or not, so on. Historically, it is most common. So you actually predict label for unlabeled data set. This is one of the examples. So typical results are underfit, overfit, and good fit. What this means is how good the model performance is. Let's say you have a model to predict if a person will get diabetes in 10 years or not. How good is the model? Is it learning well but not able to predict? That's what the fit is. If the performance is good, then it is good fit. If it is always stating that everybody is getting diabetes, then it is overfit, something like that. These terms are related to how good or how accurate the model is. So that is supervised learning. This is very commonly used machine learning technique. Unsupervised is lesser common, but also gaining prevalence these days, where we don't know what the label is, but we want to find the patterns. Given dengue occurrences across the entire city, what can we do about it? All we can do is you can classify into clusters where the dengue is more prevalent versus not. Within unsupervised learning, we have terms like self-supervised and reinforcement learning. Self-supervised is the model is automatically able to create the labels that are missing. Then the algorithm will identify what you want to predict. The next one is reinforcement learning. Reinforcement learning, the best example is self-driving cars. If you go more towards your right, then you will have penalty, which will kick you more towards left. If you go fast, then there will be a penalty, which will make you slow down. So all the positive actions will give you rewards. All the negative actions will give you penalties. That's the basis of reinforcement learning. The best example I can tell you is the self-driving cars. Action will have rewards, and the bad actions will have penalties. Yeah, the clear example here is house pricing prediction. Example here is customer test classification or lane finding in our GPS data. Reinforcement learning is driverless car. Okay, at this point, I think I want to show you an illustration of how this happens. This is more easier to understand. Supervised learning, we know the label. So given an email, you know if it is a tick, which is a right email, or no, it's a spam. So this is the label. If we have the label, then we will train. We will train the model giving 1,000 emails. Okay, out of 1,000, these 800 are actual emails, the important emails. These 200 are spam. Now learn from this, and then tomorrow when I send you a new email, new instance, help me decide whether it is a tick or a spam. That's a typical use case of supervised learning. That's how all the supervised learning examples work. The algorithm, as I mentioned here, is supervised by the labeled data. The labels are tick or not tick, which acts like a teacher. It will tell the algorithm, okay, these are the characteristics of a good email. These are the terms that you need to look for in a spam email, like cache, free cache, or free license. So these are some of the terms that you need to look out for in the email before you classify it as spam. In supervised learning, just focus on this blue part here. The goal is to learn a function that maps input. Input is your email to the output, which is the label, inbox or spam. The algorithm uses this function to make predictions. So it learns from the training data. The teacher, as I mentioned here, will learn, the algorithm will learn from the teacher, and then it will be ready to predict the next day. So again, this one here, the plot on the right, regression plot. So let's say the feature is the email. The value is whether you are classifying it as inbox or spam. When a new instance or when a new email comes, where is it? Is it spam? Is it inbox? Unsupervised, we don't have the labels. So we only know the persons who are here. All we can do is we can cluster them. Okay, this group, they are very similar because they are, for example, their height is the same. They are shortest, for example. Let's say this is feature 1 is height, feature 2 is weight. If we are classifying them based on height and weight, these participants have similar height to weight ratio, so that we are classifying here. These patients have very high height to weight ratio, so they are classified, clustered separately. Now, when a new person comes in, where do I place them? That will be depending on the ratio of feature 1 versus feature 2. If they are normal, they will be placed here. If they are abnormal or anomaly, it will be here. So here is one example where we have used this SNE visualization to show how geographically different the things are. Each color represents a particular object here. For example, this yellow here refers to the truck. The triangle refers to the deer, and so on. So in unsupervised machine learning, algorithm is given a data sets without any labels. That's the key here. There are no labels to tell which is, for example, anomaly or normal. So the goal here is to find patterns or structures. Here it has found patterns. Okay, these participants have similar height to weight ratio. So let me bucket here. So the algorithm works on its own to identify the patterns. So based on the data we have, height and weight, it will automatically cluster them into small pockets. When you don't have labels, this is a very good technique to use to give some insights into your data. So I don't want to go into detail about this. This will be a bit of overkill given that many of you are starting off. But this is semi or self-supervised learning. It is a mixture of supervised and unsupervised, where for some you have labels, for some you don't have labels. So let's just skip this in the interest of time. Reinforcement learning, I briefly mentioned, where you have, for good actions, you'll have rewards. For bad actions, you have penalties. So the algorithm takes action in an environment and receives a reward signal based on the quality. So here we have an environment where there is fire and there is water. what does this reinforcement agent do? If it goes to fire, then it will have negative 50 points. Now it will know fire is bad, and next time it will avoid. Similarly, like I gave you the example of driverless car, if it is going more towards the right and it hits the curb, it will know it's a bad action. Then it will, next time it will learn. That's how reinforcement learning works. A positive action are reinforced, negative actions are penalized. From the description of in the pit stop one, looks like there are not much examples that need reinforcement learning. So again, I'll not go into details about this. Most of your examples are supervised. Some of them might be classified as unsupervised. Okay, if you remember the earlier slide where I showed circle within circle within circle, artificial intelligence, machine learning, within which there was deep learning. Deep learning is subset of machine learning. It uses very specific algorithms called neural networks. It is similar to how our brain neurons work. And it's one of the foundation models for all the GPT and large language models. So it is developed based on neural networks. So as I mentioned, LLMs use deep learning techniques. There are many applications that we daily use. Google search uses deep learning. Many of the image related analysis use deep learning. LLMs, ChatGPT, the foundations are deep. It's good to know that it is just one of the techniques within machine learning. Just to reinforce my point, artificial intelligence enables us to mimic the human behavior using machine learning and deep learning algorithms. So machine learning, mostly it is supervised or unsupervised. Supervised is when you have labels, when you know the outcomes. Unsupervised is when you don't know the outcomes and the model tries to extract structures or patterns within the data. Deep learning is just a class of machine learning algorithms that are based on neural networks, which are mostly used for very complex tasks, and it requires lots of data. Okay. What are the other subsets of ML? Sorry, there are many other techniques like deep learning, as I told you, is classified is built on neural networks. The other algorithms are decision trees, logistic regression, random forest, and there are many algorithms that comes within machine learning, one of which is deep learning. So if you look at all the data competitions like Kaggle and other competitions, most of them use random forest. I'm just typing out the algorithms that are very popular. Decision trees, KNN, and so on. So these are some of the algorithms that are or subsets, like the person from Brunei, Zadil, mentioned. Sorry, George asked. These are subsets. XGBoost is one of the very popular techniques. It's called extreme gradient boosting, which is very powerful and has been used in many data challenges. K-means clustering, yes. Thank you for updating. Okay, let's. At this point, again, I want to pause because I have covered quite a few concepts within machine learning: supervised, unsupervised, semi-supervised, reinforcement, and so on. Do we have any questions at this point?
Yes, Srinath, the two questions in the Q&A panel.
Okay, Q&A. Where do I find it?
The first one is, how are the rewards given in reinforcement learning?
So reinforcement learning, you can program it depending on the tasks that you're working on. Like I mentioned in driverless car, the actions would be either steering more to left, more to right, or going fast or going slow. These are captured by different sensors, which are the cameras. Cameras are the eyes for the car. So the actions are penalized because we already program it. If you go close to the curb, which is within, let's say, 5 to 6 inches of the curb, then you need to be penalized. If you are within that, you are good. If you are following the you use the camera to look at the signs on the traffic board, if we are within that speed, then we are good. If you exceed that, then you'll be penalized. So these are all programmed within the code for reinforcement learning, so that all the tasks are either rewarded or penalized. It all depends on the tasks. And what's the other one? I can't see the Q&A here. Sorry.
The second question, which is quite technical, so I've typed in the chat, is from Jovinda.
Q&A, I see it now. Okay, I see it. Sorry. Regarding TSNE, does it make intuitive sense to reduce the dimension of text embeddings? If you are referring to this particular plot, then maybe yes, you are right, because we wanted to capture the essence of that. That's why you might not see in clear, but yes, you are right. We could, depending on the need for depending upon the story that you're telling, you either zoom in or zoom out. Here I just wanted to give you an idea of showing different clusters, which are pretty similar to this one. I just wanted to make sure that it captures different clusters. But yeah, you could do it, Javinder. Thanks for the question. Yes, it does make intuitive sense. Yeah.
If there are any other questions, maybe either type in the chat or Q&A, or even raise your hands and use the mic if you'd like.
Yes. Please feel free to use the mic as well. I'll keep the Q&A open as well here. What are the rewards given? Yeah, the 3 questions. Okay. Okay, I think while you're thinking about the questions, please also help us to answer these 2 questions. What is your approach for learning new skills? Which of these issues you think data science could help? Basically, which are the low-hanging fruits? I think I will also answer this question verbally, at least. My to-go approach is actually first 3. I watch tutorials, I read lots of blogs and write elsewhere, and also hands-on practice. I think one other way to quickly learn any new skill is to find a buddy and talk about the topic itself. That will enable your learning, or teach a new person what you have learned, which also falls in group learning. So I use all the 4 techniques. This second one is interesting. Plastic waste in oceans, carbon emissions from transport, food waste from sustainable farming. Interesting. So related to climate, I think I've worked with one of the doctors in my hospital. The doctors are anesthetists basically, who give you anesthesia during the operations. So while the answers are coming in, I just want to share this story. So we recently found that the gas they give you for anesthesia is nitrous oxide, also called as laughing gas. We found that about 80 to 90% of the gas leaks, and it is not good for climate. So we found a way to first to quantify, like I told you, a descriptive, diagnostics, predictive, and prescriptive. First, we described the problem, because there was no article that described what is the magnitude of the problem. So now we described, then we diagnosed why is it, then we predicted what will happen if this continues, then we prescribed, okay, we changed the existing setup from whatever it was to another setup where the emissions are lesser. So this is one use case where we use data science for climate related issues. Okay, we have about how many 24 participants out of 40 who have answered. That's very good response. I'll just open the poll for 30 more seconds before we discuss the poll results. Any questions? No more questions. Okay, I'm ending the poll. Okay, so 50% of you hands-on practice with tools. That's a wonderful way to learn. And 42% of watch tutorials. Yeah, these days, instead of searching on Google, I first search on YouTube. Or if I search on Google, I directly go to videos to quickly learn. Reading articles, I think that's a good way for me. I usually go on, when I go on public transport, I used to read. Okay, second one is issue. Which of the climate issues do you think data science? Majority of this says food waste and sustainable farming. Second is the carbon emissions from transport. Can one or some of you just type in the chat, how do you think, or what is the problem statement that you would solve for the food waste and sustainable farming? It's interesting to know that data science can be used for food waste. Maybe you can quantify it, but what can we do about it? Maybe if you have some thoughts, you can share. I think whenever you have the thought, please share it in the chat, and then we can discuss further. In the interest of time, I'll just proceed. Natri, do you want to take over?
Yeah, sure. I'm
Thank
more
you.
than happy. Thank you, Srimat.
I'll be on
Thank
mute.
you, Srinath. Yeah. All right. Good morning, everybody, and thank you so much for joining us today for having a DataKind Singapore. I'm Ratri, also from DataKind Singapore, and now I'm gonna take you through several case studies that where actually we can use data science to help solve the problem in the space of climate and sustainability. A little bit introduction about myself. I happens to work in the space of sustainability based out of Singapore. I do a little bit in terms of data and climate. Most of my work are related to geospatial. Still learning on that space because the space itself is evolving very fast, but it does really help helping us refining the problem and finding a working solution related to the climate and sustainability. So without further ado, I will proceed with the question of what are the data scienceable problem for climate and sustainability. Next slide. Actually, there's a lot, but if I can wrap it up into 4 main areas, I would say the first one is exactly tied up to what Srinath have mentioned earlier, is about you quantifying it. And that relates to enhancing the data accessibility to unlock the previously untapped data source for climate analysis, trend monitoring, and sustainable planning. So using the case studies about the laughing gas that Srinath has mentioned earlier, it's because we don't know what we cannot measure, right? And we cannot manage what we cannot measure. So the first thing that we need to do is always, what do we know about that particular that particular problem? In this case, in Srinath example just now, there's a gas and we cannot see it, but surprise, there's actually a way to be able to quantify, to measure the gas leak, and that is by knowing the data related to gas leak, it allowing us to proceed with the next step and identify what can we do about it. The other area in which data can help for climate and sustainability is actually employing an advanced quality assurance. It's improving the data accuracy and confidence. Everything in this world is actually measurable, and there's a math everywhere, and that's where helping us to measure everything that initially it's almost impossible to measure. And when you be able to measure it, then you will be able also to improve the data accuracy and be more confident with the decision that you're making. The third one, it's expanding the use of data for predictive insights. This is very, very important also when it comes to address a climate risk, especially if you know now how the weather is, I would say, behaving quite erratic. One time it can be raining so heavily, the next day it becomes very hot. By seeing the pattern of how, let's say, the climate has changed, that are also allowing us to do something about it and making a more informed decision, or as well as optimizing the resources that we need for that particular condition or situation. And the fourth one, or the last one, is actually helping the climate and sustainability practitioner with the data-driven tools to train or translate a more complex data. It can be related to the food waste. It could be related to the plastic waste that are being produced, because there's a data somewhere sitting of how many, let's say, plastic packaging are being produced by brand A or by brand B. So that will also allowing the practitioner to take action, a more effective action on how, let's say, you want to solve issue related to plastic waste that goes leak into the ocean. So this is actually the 4 possible space in which data can be helpful for that. Next slide. Aside from that, in general social space itself, there's lots of opportunity in which data science can help. It can better, one is to better understand the community they are serving or the customer they are, in which they are providing services or product. It can also save people or resources time by automating processes. Also provide a better target effort, finding like who actually need these services. And then also scale services and providing a more personalized support. If we move for this particular one, if we move back several slides earlier, in which we can do a customer segmentation using unsupervised learning, that actually based on the behavior pattern from a different target group, you can actually identify that maybe this kind of services be more suitable for segment A, and another kind of product or services is more suitable for segment B. This is this kind of an insight can be elicited from the use of data science. Another opportunity is actually to use open or external data sources to inform decision making, as well as anticipating future needs. Don't worry, I will take you through to some of the example of the project that we've conducted in DataKind. Next slide. So a bit about DataKind itself. I mentioned earlier. Basically, DataKind is a nonprofit organization. We launched 12 years ago in the US with the idea of a very simple idea on how we can help a nonprofit around the world be equipped with data science, because as we may know, data science is expensive resources for most nonprofit organizations. There's lots of costs involved when they want to have a data scientist in-house. So what we did that time, the Jack Potter as the founder of DataKind, actually, how about we organize a group where a data scientist that happens to work with the government or with corporates like Facebook, Google, Microsoft, all these MNC corporates come together and provide a pro bono services and help this nonprofit improve their data capabilities. And that's exactly what we do. So 14 years down the road, we are now a mission-driven organization that we help nonprofit organization, government organization, as well as social enterprise to solve some issue using data science. Next slide. We are working all over the world. we have project running all around the world. You can check about us on the website later. Next slide. But overall, we have 5 chapters spread across the world. One of it is in Singapore. We also have chapter in India, San Francisco, Bangalore, and UK, as well as Washington, DC. Next slide. So we have done several projects related to climate and sustainability, and I will take you through all this project that hopefully can give you a better understanding of what we do. So the first project that we did is related to agriculture and using data. What happened is that, just to give you a bit of a background here, one of our projects actually ran in Ethiopia, and we work closely with Melinda Gates Foundation, as well as the farmer on the ground. So in Ethiopia, what happened is that wheat rust can be devastating for the local farmer in Ethiopia. And that really makes the Gates Foundation, who've been working closely with the farmer on the ground, wonder how can we use data to help predict and prevent wheat rust? Because what happens is this wheat rust can really affect the crop yield and hence affect the income for the farmer. So what we did is that, next slide, we use a survey as a combination of survey, remote sensing, and satellite imagery data to develop an algorithm that could identify wheat rust from space. What we did is that we combine all this survey data, remote sensing data, satellite imagery. Then we developed a proof of concept statistical model where to distinguish a yellow rust from no rust. I don't want to be too technical here, but there is a capability in geospatial analysis where you can differentiate and contrasting different color band, and that allowing us to kind of identify a farm field where it has a yellow rust and some farm field that may not have or have a low wheat rust. So we differentiate that, and then that the proof of concept of statistical model that we have is actually allowing us to come up with 82% accuracy. Next slide. And using that model, what happened is that we are able to build a more accurate predictive model using a combination, again, a satellite imagery, multispectral imaging, and computer vision technique. The next question is, who's going to use this data? Well, this data is being used by Melinda and Gates Foundation on the ground to identify which farmer actually have a high risk for wheat rust. That means that they should be the first farmer to be helped, to be assisted, so that next round of crop farming, it's have a less risk of wheat rust, and then they have ability to improve the crop yield, improve the crop health, as well as have a better harvest result. So this is the first example of how how data science actually being used in the climate and sustainability space. Okay, I will pause it here first. Is there any question? Okay, I do see some question. Is the satellite data used for this is open source data? Yes, we did this project a while ago, and then it was open source data. Up until now, if you use a Google Earth Engine, it's still an open source data. You have some open source data, but like Landsat 2, Sentinel, all these are open source, and you can use it for free. The cost usually will come in the cloud processing for your virtual machine, as well as your computing. Because what happened on this project, usually you need to have multiple numbers of image of a satellite imagery, and then you train the machine to identify which area actually have a wheatgrass, which area is not. You contrast one another. Because this is more on the supervised learning, because you have to label each of the data sets to see, okay, this specific image of a field from the space, like what it shows on the screen, is actually, oh, that area is actually have a wheatgrass. Then you label it as high wheatgrass, let's say. And then another image may be, this one is low wheatgrass. Then the machine will computing it and then come up with the result. That processes, that is where usually the costs involved. It is SAR. I think for this, if I'm not mistaken, I have to go back to the technical part of this. There's various open source data. It's really depend on the type of a project that you use, but I can get back to you on which list of open source data that we use for this particular project. Would that be okay, Jelo? Awesome. Okay, let's move on to the next one. The next case studies, interestingly enough, is aligned with the question that we have in the pit stop 2 on which of this climate issue do you think data science could help solve fastest. Interesting enough that there's two people that say water conservation is actually a climate issue that can be solved with data science, and that's actually very correct. And the example that we have here is actually on forecasting urban water usage in the US. This project, again, done by DataKind, in which it was for Molten Niagara Water District in Southern California. If you know a bit about California, is actually have a high water stress level, and they actually have several, face a drought issue quite frequent. So what happened is this MNWD actually is a government agency that provides water, recycled water, and wastewater service to approximately 170,000 people across several cities in South California. So when you are a government body that is working to provide water on a drought or high water stress area, you actually need to have a very good and strong forecasting capabilities to understand how the water being used in the urban setting. Like, as you may know, urban using water quite often, not only for day-to-day activity, but also to support the running of the infrastructure. And I just want to touch base also how currently with this growing AI capabilities, one of the issue is how all the data center actually using water resources to cools down the data centers due to the high demand of AI. So that also adding another layer of stress for urban water management due to the growing demand of technology and AI. Anyway, back to the challenges here. So what happened is that Molten Niagara Water District actually need help to be able to precisely and more accurately forecast the water demand, to improve the pricing, as well as expanding their conservation program and be able to implement initiatives to increase the efficiency of water transportation throughout its network across several cities. So what we did was, what DataKind did is we used 12 years data, historical data from the MNWD, including data related to the water usage, with weather data, as well as census data on the household characteristic, and then using that data to forecast the demand for its irrigation customer that use high volume of recycled water, as well as other segment of customer, including a household customer, to create an open source dashboard that can predict the recycled water demand in the Malton Nigel water district. Next slide. So what happened is
Ratri,
that,
there is a question.
yeah.
Could DataKind teach how to collect data about food waste?
We can help you scope it,
Yes.
but it will be a different section, because there's lots of element that needs to be think through when we talk about food waste. But it is possible.
I think the key thing about this is what are we trying to solve about food waste? And are we trying to know how much food is wasted, or whether it is not reaching the right people? I think the problem probably need to be scoped, and then we need to think about how are we going to collect the data on this. That would be typically how we approach such issues.
Yeah.
So Daniel, in short, I think we can definitely help you scope what are the elements that goes to collect, but with the actual data collection should be done by you or your team. I hope that answers your question.
Awesome. Cool. Thank you, Renat.
Okay.
All right. Yeah. So what happened is that from this project, and by collecting 12 years of data, we are able to develop a proof of concept on water demand forecasting model using the flow of data at the micro zone level. And then we are able to create a data infrastructure and dashboard that able to help the agency to save money, save costs in the capital storage costs, especially. So if you look at this particular chart, is what happened is actually the blue line is what the forecasted demand is with the confidence band. So if the blue line shows any chance of reaching or exceeding the maximum supply estimate, which is the red line, it's signal a warning to the agency analyst. So this is a dashboard that then being used internally by the agency team, so that the analyst can then use this to better manage the future resources by reaching out to the largest water consumer and request them to reduce the usage for the period or shift their schedule. So this is allowing to manage the resources better. So that's what actually happened in this project. And this actually allowing also the state government to, in California, to have a unique water manager-led public-private partnership that can bring together different stakeholders in the state to leverage the data to help water manager ensure reliability as well as sustainability of the water usage. Because I think water is a very, very critical issue. Like people's needs water, but then also need to identify how you can still use the resources optimally instead of using it too much that then at the benefit of other users. This is actually how helping also help the agency, as well as the California government, to prepare for future potentially worse drought by having this dashboard coming together. Any questions so far?
I don't see any questions, but I just want to add one point. I just want to relate this slide back to our descriptive, diagnostic, predictive, and prescriptive. So this one handles all four. You describe the data, you analyze it, what the problem is, and then you also predict with the blue line if it is what is the forecast in the future, and then you also take action if it touches or goes anywhere near the red line. So it's a classic example of using all the four analysis, and this is done by DataKind as well, so we can help you with such analysis.
Cool. Perfect. Now move on to the last case. This is actually the latest one from DataKind, where we actually what we do is we optimizing a service delivery. So this project is actually conducted. First one is in Haiti, just after the natural disaster that they had back in 2019, and then from there we expand the use the same tools or the same data science machine learning solution to another organization in Kenya and Peru. So what happened is that the issue is the organization needed a solution that can help them manage the cost and logistic when they transporting their product and services. In this case, is a sanitation product. So it's what we call a toilet. So in some in some country, let me backtrack a bit. In some countries where specific area doesn't have a proper sanitation infrastructure, they need to create a mobile sanitation station to serve the community, to prevent open defecation that have a high cost for healthcare, right? For public health. So what happened is this the cost to transport and managing this mobile toilet can be quite costly. And for them to be able to bring down the cost lower, but still effectively serving the community, is they need to optimize their route. Just like, think about it like the postal services in your country. They have to identify which route is the most efficient for the postal person to deliver all the items that needs to be delivered, or collect items from the area that they needs to collect in the most optimal way. So the same logic is also needs to be done for this organization. Given their limited capacity, given to the challenges of the area they are serving, it could be the area where it's very remote, high elevation, where big cars or truck will not be able to pass the road, or it could also be a challenges due to the mobile network that is unavailable. So they have to make sure their truck driver or their driver knows the route, because there's no connectivity. They cannot see the map. They cannot see it on the map. So take into account all these challenges. What DataKind did is that we leverage an OpenStreetMap and Google OR tools into an easy to use optimization tools, which the output can be sent to the driver phone, which mostly using Android because it's open source, to output the map and text instruction to optimize route for the driver. That way, the organization that use the tools be able to save time as well as the fuel. and they can reach an area which is almost without a mobile or network access at all. So as a result from this project is actually we have a route optimization software that able to transport logistic in the very low resource setting. Like I mentioned earlier, it could be lack of reliable or affordable private or public transport, long distances, challenging terrain, high elevation, or lack of infrastructure, or when they or to the area where they have a low fuel availability as well as pure connectivity. We're actually expanding this route optimization software not only for the sanitation's project, but can also be used for medical delivery, also food delivery for people in the remote area or people who actually immobile, let's say elderly, or it can be anything related to service delivery. So yeah, that's overall 3 case studies in which data can be used for climate as well as for sustainability problem. Move forward. So the question is like, wow, this is so great, but where should I do? What should I do? Where should I start? That's always the question that people have in mind. So I think there's a several layer that you need to keep in mind. The first layer is the data science. What is the tools that you want to use, right? And these tools, it's sometimes that you need to keep in mind is not how sophisticated the tools is, but what tools is the easiest to be adopted to your current system, to your existing system, as well as to the people who are going to use the system. Because no point of having or building a sophisticated tools, but nobody can use it. That would be waste of resources. The second layer is your data infrastructure. Because whatever you build, especially when it comes to data science, when it comes to machine learning, your algorithm is as good as your data source. If your data source is good, then you will have a good result. If your data source is not good, then the result will also not be as good. There's a term in machine learning and AI, I think Srinath Wibang or many of you might heard, garbage in, garbage out. So if what you put is garbage, you cannot in any change the output become great. It will remain a garbage and not be able, it won't be useful. And then the third layer is your data strategy and your value. That's where how you build your foundation. So moving forward, I think I would like to wrap up the session by highlighting 2 things that we always keep in mind in DataKind is that AI does not replace, it supplements. So we in DataKind, we aware that AI is not a solution for everything. There's some issue that can be solved using AI or using data science, but there's also enough problems that cannot be solved solely by data science itself. So what we need to do is that forget about algorithm or model. It's about learn how to solve the problem first, exactly what Wibang has mentioned earlier. Start with problem and then see how AI can help you address or build solution with that problem, sorry. And again, AI and machine learning is one of the tools that can accelerate the sustainability and responsible progress, but it can also become another source of problem if not being careful. So that would be one of the area that AI cannot, it doesn't replace, it's actually supplement. The other part of it that we need to keep in mind also that, like I mentioned earlier, AI model are only as good as your data pipeline. What does it mean? It means that you need to focus on the data. Make sure that your data sets are good, have a good quality, are representative of your entire population or sample and have a zero bias. That's always the big things in AI. Again, it's always, we always emphasize on zero bias, zero bias, zero bias. You need to clean and annotate and sculpt the data. You have, so whatever data that comes to your table, you need to be, you need to scrutinize it. You need to understand who gets included, who gets excluded in the current data sets. So exactly from plastic waste to carbon emission to food waste or water conservation or any kind beyond sustainability and climate, you need to understand who gets included, who gets excluded, how the data is being collected. And then always, and again, AI and machine learning and data science itself, it's never one, it's never like 0 to 1. It's a continuous loop, feedback loop, right? So you need to find out how you can improve the data collection, to the data processing, the data accuracy, so that this continuous loop are improved as well, and you get a better result as you move along the processes. And the last thing is, again, AI, machine learning and data science is the tools, but it's still run by people, run by us. So it's always important to highlight on the ethics and the value. What is this ethics and value look like? It's about how diverse is your team? What is the equity in the data collection practices? Who collects your data? Is it collected only by one person? Who is that person? How often that person collecting it? How often that data collection processes are being evaluated? Have you done any inclusion practices when you audit the data? Again, asking who being included, who being excluded. You also can see the cost benefit analysis, check assumption and risk when you do a scoping. You can do review and user research, because again, when you do a user research, then something that usually when you identify, hey, there's a different segment in my user, and that will also mean there's a possibility of different data sets. There will possibility of different data implication. Model transparency. One of the things in AI and machine learning is like how transparent it is and how explainable the model is. If you cannot explain the model, then most likely there's an issue there. Test and test and test again. Mitigates any bias. Again, continuously monitor and access, as well as keep it open, get into the open resources. That will be a few places where you can start taking into account ethics and value when you build a solution using AI and machine learning. There are, next slide. I already covered this, I'm so sorry. Next slide is, this is a several example of a modern data stacks that you can use. You don't have to use everything. There are several options that you can use. Moving forward is resources that you can use to apply what you have learned so far. There are several resources provided by three biggest cloud provider, Google, Amazon, and Microsoft. I think we can share the slide later so that all this can be each of the participants can have a look as part of their solution building phases as well. I will not touch base on that. Yeah, also end-to-end tools. Again, like Srinath has mentioned earlier, as the AI and machine learning evolve, there's more products available that is more cost efficient, open source, requires a less coding. I mean, just use a drag and drop, though just be careful with that. Usually there's a catch when it comes to this no code deployment, but it's a good place to start when you want to build a simple solution. So yeah, with that, any question?
Thank you, Ratri and Srinath. Yes, any questions, feel free to put in the Q&A chat or raise your hand, ask. Maybe while people are preparing the questions, I think Zee had a question on good sources to learn ML techniques, Srinath, that
Yes,
you wanted
I
to
already
respond to.
messaged him in private. I thought I had a direct message, right? Was it there a question? Oh, okay. There's an open question as well. Okay. I already responded to the person in private.
How about maybe for beginners, what would you suggest would be a next?
In terms of data science, is it? I think I can
Yeah.
share a few things that I shared with few courses that are available free, that are available at a easily accessible medium. Maybe we can start off with that. There are plenty of that. It's just like a buffet of options you have. Just go through the description of each course, see if it is relevant to you, and then choose one of them. All of them are at a basic level, so it's good for everyone to get started there.
Awesome, thank you. I'm also looking at the list.
I think just to add from my side, I know there's lots of to digest at this level, and with the solution building, there's several problem statement that you or idea that you have in mind. It's always good to have a follow-up conversation, and I'm open to do that as well. So yeah, you can add me on LinkedIn. You can drop me a message.
Yes.
Yeah, I'm more than happy to. I mean, we are from DataKind. I'm more than happy to field any question and answer whenever we can. Cool. I think if there's no question,
Yeah,
can
there's
you
one
post this in
question
Discord? Yeah.
asking, can you post this in Discord? How do I do that?
Yes, we can do that because the participants are all on Discord. If any participant would like to help post it on Discord.
So this one, the chat history you can save, right?
Yes.
Yeah.
Thank you. I would also like to add that there are quite a number of DataKind volunteers who are also volunteering their time as technical consultants for the solution building phase. So yes, which is a good opportunity for me to say that the technical consultations and pitch coaching sessions are already out and available for you to request. Sessions start next week. Right. Yeah, so please make use of volunteers' expertise and experience. They are not here, so like the technical consultants and DataKind volunteers are not here to build the solution for you, but they are a resource for you to get advice on whether your ideas make sense, what kind of maybe software you could look at, things like that, right? So even if you're not quite sure what you want to work on right now, they are a resource for you to sort of bounce ideas and get feedback. Yeah, make use of the expertise. So please go and book those sessions. With pitch coaching as well, you don't have to have your pitch deck or pitch all ready to go before you start booking sessions. You can do them right now at tomorrow's Entrepreneur Thinking Workshop. There will be a session where you already start building your pitch. So once you have something, you'll just book a session, pitch it, get feedback, right? Even if you're just pitching maybe the problem part of your pitch, just go for it. Yes.
Cool.
Yeah, Srinath, Ratri, any closing?
Yeah, sure. I just have one more slide. So just a good segue from Yokping just now. So there's a 3 question that I think I hope this is helpful for everyone that going through the next phase of tomorrow with the pitching, as well as the solution building, as well as demo day, even further beyond this program, is that I have these three reflection question that you don't have to answer it right now. Like, you think about, just read this question, think about it, sleep on it, and then as you move along, hopefully this is kind of a question that can help you guide and refine your idea moving forward. Is that you can start by questioning like what climate or sustainability problem that you're passionate about solving with data science. The second is like, for whatever problem that you have in mind that you're passionate to solve, is that how would you approach this problem using data science? Again, don't start with, oh, I want to build a sophisticated solution. Don't. Start with the problem and just identify what data sources or technique that might be useful for tackling this problem. So think about the problem first, and where do you get the data from? What is the data source? That's it. From that, evolve your idea, and as you work through the week, find out what new idea, what question that might help you deepen your understanding of the problem space of the problem. So identify the problem space first, and identify what all data sources is available. How are you gonna get it? And from there, you slowly build the method on solving that problem using the data that you have, so that when you come up into the solution at later part, your solution is built based on data instead of just your intuition, or instead of just your observation. It can start with your observation. If the problem comes from the observation that you have from your surroundings, that's great. That's the first step. The next step is, can you find the data to back your observation and build that solution along the way? Yeah, I think that is the last from my side. Thank you so much.
Thank you, Ratri. Thank you, Srinath. I think those are very useful reflection questions as you all go into your entrepreneurial thinking workshop.